Welcome! Introducing our own innovation, developing Python-based engineering toolbox, essential for navigating the complexities of modern engineering tasks. With this powerful toolbox, it may increase efficiency and innovation in your engineering projects. So let me introduce you the programmers of this program. Rizal Lorraine D. Cadiz, Rachel G. Cueto, Tricia Denise M. Perez, Angeline R. Blaton. These are the parts of the study, so now, let's tackle each part, which begin with the overview.
Mathematics has always been part of students' lives, especially engineering students. Leaving it out restricts students' access to a variety in vital courses, which in turn restricts them in employment prospects in the future, and robs society of a potential source of literate individuals. For many professions, particularly in those in science, technology, and engineering, it is essential. Yet, mathematics is commonly perceived as difficult. Even more, now that math-related courses are more complex, frustration in understanding unit conversions and memorizing formulas is evident. Therefore, developing a Python-based engineering toolbox is essential in aiding engineering students in their day-to-day tasks by providing a readily and accessible functions and tools in various engineering disciplines. As engineering students, they frequently have to solve problem sets and complicated tasks, so providing an all-in-one toolkit would help them save time in calculations or whenever they have to complete a project. Engineering students can now work more efficiently and effectively across a range of disciplines when they have an access to a toolbox built using Python, which promotes accuracy.
I'm here to explain the objectives of our study. The initiative is driven by the following goals. First is to ensure the content of the toolbox covers a wide range of engineering disciplines such as civil, mechanical, electrical, and chemical engineering. This objective is foundational as it ensures the toolbox relevance and usefulness to engineers across diverse fields, making it an essential cornerstone of the project. Second is to incorporate machine learning algorithms to automate repetitive tasks and provide intelligent insights, thereby empowering engineers to make informed decisions more efficiently. Automation through machine learning not only enhances efficiency, but also represents a cutting-edge feature that can significantly elevate the toolbox value proposition, making it highly important. Third one, it ensures fast execution times, especially for complex calculations and simulations. Performance optimization is crucial to ensure the toolbox usability and responsiveness, particularly for engineers working on time-sensitive projects or dealing with large datasets, thus ranking this objective as highly important. Fourth is to integrate advanced data visualization capabilities, allowing engineers to analyze complex datasets with ease and precision. While data visualization is essential for data interpretation, it ranks slightly lower in importance compared to performance optimization and broad discipline coverage, but it remains critical for enhancing user experience and insights. 5, or the fifth one, it allows users to easily extend its functionality by adding new tools or modifying existing ones. While flexibility and extensibility are valuable features, they are slightly less critical compared to the core functionalities of the toolbox. However, they still contribute significantly to the toolbox's long-term usability and adaptability, warranting attention but ranking lower in immediate importance. These objectives serve delineating the key areas we aim to address in the development process. By articulating these objectives up front, we can align our efforts, set expectations, and ultimately deliver a toolbox that meets the needs of engineers across various disciplines.
Methodology, the functions and its use and description. Import, an essential feature of the program which imports certain modules, allows the use code from other files or libraries in the current program. Def, this was used to define the function, which also signifies the beginning of a function block and is followed by the function name and parameters. Return. Return is used inside the function to return a value back to the caller. It terminates the function and sends the specified value as the result of the function call. Display menu. Display menu represents a custom function that is likely designed to display a menu of options to the user for interaction within a program. Print. It is used to display output to the console or terminal. It takes the input argument and prints them as text. While true. While true is a loop in Python that continues indefinitely as long as the condition true holds and commonly used for running continuous processes until a break condition is met. Try. Try is used to start a block of code that will be tested for exception and followed by a block of code that may erase an exception. Except. Except provides in conjunction with the try statement to define a block of code that will be executed if an exception occurs within the try block. Main. Main is used as the entry point and typically contains the main logic or function calls of the program. Input. Its function is to take input from the user throughout the program. It displays a prompt to the user and waits for input from the keyboard. If or elif or else, usually used for decision making. If is used to check a condition, elif allows for multiple conditions to be checked, and else provides a default action if none of the conditions are met. Get float input indicates a custom function that likely retrieves input from the user and converts it into a floating point number for further processing. Break. Break is used to exit a loop prematurely and commonly used to break out of a loop when a certain condition is met.
The project features focus on the following key aspects. 1. While loop. The program uses a while loop to keep the program running until the user decides to stop. This loop ensures that the user can keep using the program without it closing unexpectedly. Number 2. Menu options. The code offers different menus with choices for various kinds of calculations, like finding areas, volumes, mechanics, or converting units. These menus are shown using special functions like display underscore menu, open parenthesis, close parenthesis. The third one is input validation. The code includes input validation to ensure that the user enters valid numeric values when prompted and achieved using the get underscore float underscore input open parenthesis close parenthesis function, which repeatedly prompts the user until a valid numeric value is entered. And lastly, number 4, calculation functions. It defines numerous functions for performing specific calculations such as area calculations, volume calculations, mechanic calculations, and unit conversions. Again, this is Group 6. Thank you for watching and listening.